going over the homework with exercise 8.4 question 12 when you were, so we're looking at your results from differentiating from first principles. Now these were the 4 examples here in the booklet. I'm just going to go straight to the textbook first. So exercise 8.4 question 12, when you started off with the function y equals x squared, or I can write function of x equals x squared, you ended up with f dashed x is 2x, right? When you differentiated y, or function of x equals 4x squared minus 4x minus 3, you ended up with 8x minus 4, and so on. So I could write out, so we've written out each question, what the question was, and the what we got when we differentiated it. And what we're going to do, I think with this one here in E, you can sort of see a pattern. So y equals x cubed, the derivative is 3x squared. So it appears that the 3 comes to the front, and then you drop the power of the x by 1. Okay, now let's look here. So let's look at that. So we bring the 2 to the front, so your function is x squared. So what we do, we bring the 2 to the front, and then we drop this power by 1. Okay, now this is 4 times x squared. So we keep the 4 there. So the derivative, sorry. So the derivative will be, so we keep the 4 there because your function really is 4 times x squared minus 4 times x minus 3. So just with this one, so that's what it is there. So I'm just breaking it all up. So remember we said we bring the 2 to the front, so it's 4 times, bring the 2 to the front, write the x out and drop the power by 1. Minus 4 is the constant, it stays there. This x to the power of 1, we bring the 1 to the front, write the x and drop the power of the x by 1, and 1 minus 1 is 0. And here, minus 3 is really minus 3 x to the power of 0. So that's minus 3 times, you bring the 0 to the front, x, and I suppose you drop that, but it doesn't matter what this is. I drop this by 1, 0 minus 1 is negative 1. Look, it really doesn't matter because this last term is minus 3 times 0, right? So you end up with 8x minus, well, you just get 4 here because x to the 0 is 1. Now, I know that looks really complicated there and you won't do it like that, all right? But we're just trying to come up with the general rule, okay? So what appears to happen is that the power of the x comes to the front, you write out the x and you drop the power of x by 1. This 1 comes to the front, you write out the x, 1 minus 1 is 0. Now we know x to the 0 is 1, so you just get 4. So that original function there was 4x squared minus 4x minus 3. Now, basically, we can see that when you differentiate the constant, you get 0. Okay? So you differentiate a constant, you get 0. You differentiate an x to the power of 1, well, that just ends up becoming x to the 0, that bit there. You just end up with the constant, with the coefficient. So when you differentiate just 2x, negative 2x, whatever, you just get the coefficient. You drop the x. So basically with differentiation, you're dropping a power of x. All right? But this is why it works for constants here, like how we get, why the constant drops off, because it's 3x to the 0. The 0 comes to the front, write the x and drop 0 minus 1 is negative 1. You know, x to the negative 1 is 1 on x, but you're multiplying by 0 and you get 0. Right? So if you start off with that, so you basically bring in the 2 to the front. 4 times 2x is 8x, and we're dropping the x here. All right, we're dropping a power of x. See here that it's 5 times, bring the 2 to the front, right? How did we get that? We did 5 times, bring the 2 to the front, drop the power of x by 1. So you get 2 minus 1 is 1. Minus, you drop the x, but you're still left with the coefficient. And then when you differentiate a constant, you get 0. So that's why we've got 10x minus 1. Okay, the next one, x cubed, that's nice and simple. Bring the 3 to the front, x, and drop the power here by 1. 3 minus 1 is 2, 3x squared. This one here, remember that is 2 times x cubed, so the derivative ends up being 2 times, you've really got the 3x squared, are we okay with that? Plus, remember when you're differentiating something just with x to the power of 1, you just get the coefficient, because you're dropping a power. because that's 5x to the 1. The 1 comes to the front. You end up with x to the 0, which is just 1. So that's how we get 6x squared plus 5. Sorry, you can't see the 5. This one, again, dropping the 3 to the front, 3x squared, dropping the power by 1, minus 2 times 2x it will be. All good? Plus 3, dropping this power by 1, because that's 3x to the 1. And when you differentiate a constant, you get 0. And this one here, your f dashed x, you've got your negative 2 times, and you're differentiating the x cubed, you get 3x squared, and that's why you get negative 6x squared for the derivative. Okay, so that's your pattern. But sometimes the patterns might be a little bit harder to see for ones like these. So these were your examples, that's fine. Okay, 2x, and you drop the constant. You differentiate the constant, you get 0. This one's fine. 2x plus 5 is the derivative, but this one, how did we get this? So I'm looking at example 4 from your booklet. Your function of x is x to the power of negative 1, which is fine. So what do we do when we differentiate? Don't we drop this, don't we bring this number to the front, the power to the front, negative 1 to the front, x to the, and don't we subtract 1 from this power? What's negative 1 minus 1? So I've got negative 1 x to the negative 2. Oops. Got it? So I started off, please, your notation is extremely important. I've got function of x is that, x to the negative 1. F dashed x, I bring the power to the front, negative 1, write out the x and drop the power of x by 1. I've got negative 1, take away 1. So it's negative 1 times x to the power of negative 2. Isn't that negative 1 over x squared, which is why we got that result when you differentiated from first principles. And example 3 from your booklet, differentiating from first principles, we've got function of x is root x. But, you know, we're supposed to bring the power to the front and drop the power by 1 of the x. So we write root x as x to the power of a half. Now, what's our rule? Bring the half, so you must write f dashed x equals. Now, if you get the notation wrong, you lose the mark. You can't write function of x on the next line. It's wrong. F dashed x is the derivative function. So you bring the half to the front, don't you? Then you write the x, and now what do I write? A half minus 1. I'm just showing all working. You'll be able to do it in your head later. So it's a half, x to the, a half minus 1 is negative a half. So negative a half means 1 over x to the power of a half. So I've got the 2 on the denominator, and I've got x to the half on the denominator. Are we okay with that? Yes, no, right? X to the negative a half is 1 over x to the half. Now, because the question is written with square root signs, you must put the answer in the same format. So this is 1 over 2 root x. And we differentiated this from first principles. That was our example 3 from the booklet. So that's the short method of differentiation there, okay? Now, we're just going to watch a quick video. It's about 8 or 9 minutes that formalizes that all. Okay, with some more examples. If you're asked to differentiate something, we're just going to differentiation notation. We're just going to look at the different ways of the notation, differentiation notation. You might be asked to differentiate. What if I just say to you, e.g., differentiate, I don't know, 6x cubed minus 4x squared plus 5x minus 3. I might ask you to differentiate that. Now, I haven't said that y equals that or function of x equals that. So we can see that this is a function in x. You could write this out. You could write your answer 3 ways. You could write it, well, my function of x is 6x cubed minus 4x squared plus 5x minus 3. Now, if the question's presented this way, your derivative is f dashed x, okay? And what's my answer? 6 times 3x squared, what do you get? 18x squared minus 4 times 2x is 8x plus 5, and you get the 0. Or I could write it like this. If I'm asking you to differentiate that, I could say, well, I'm going to let y equal 6x cubed minus 4x squared plus 5x minus 3. So if the question's given to you as y equals this, you can write your answer two ways. You can go dy dx. Now, it's the rate of change of y with respect to x. Remember all that work that we were doing on gradient of the tangent to the curve was the change in y? We were doing gradients. Now, a gradient is the change in y over the change in x. It's a rate. All right, and the gradient is the rate of change of y with respect to x at that point. So instead of writing f dashed x, you can write dy dx. All right, so the derivative, this is the derivative. dy dx is the derivative, and it's 6 times 3, we've got, again, 18x squared minus 8x plus 5. Or I can write it like this. If y equals 6x cubed minus 4x squared plus 5x minus 3, you can write your first derivative just as y dash. So it's like this, f function of x, f dashed x. A dash is your first derivative. So there's three ways to write it. If your question's presented as function of x, you write f dashed x as your derivative. If your question's given to you as y equals, you've got two options. dy dx, and why is it dy dx? Because you're differentiating y with respect to x, all right? Or you could write y dash, which would be 18x squared minus 4x plus 5. Now, just another thing with notation. Sorry, minus 8x plus 5. Now, WOMS, if I gave you 4h squared minus 3h, you could write, how could you write it? You know how I've got dy dx? What would this be? dy dx? What would this be? dg dh. Okay? All right. yx dy dx. Got it? This would be, so if g equals that, you could write g dashed or dg dh. All right? And I'll show you another way. So dg dh would be 8h minus 3, but I could also write, you know, is this a function in g or a function in h? Look up here. That's a function in x, isn't it? So this is actually a function in h. So I could go function of h equals, so if that's my question, and I have start off with g equals that, I could do g dash for my derivative or dg dh, right? Or this obviously is a function in h. I could start the question as function of h is 4h squared minus 3h. So how would I write that derivative? If the question's given like that, what do I do? F dashed h is 8h minus 3. Okay? So that's notation.